one thing I wanted to sort of take a step back and show you is, which maybe you've been wondering about, I certainly was, is what exactly is that relationship between the percentage of games won and that performance gap? Like, what is that? Like, yeah, clearly I'm looking it up in a table, but do I have to look it up in a table, or is there a formula? Is there an arithmetic expression that can take this number and just directly give me this number without having to look it up in a table? I haven't been able to find it, but maybe some of you are better at math than I am, and maybe you can find it. What I did is I just took data from TennisRecord.com. I actually scraped TennisRecord.com. I scraped over 20,000 matches that had been played in 2023 and the first month of 2024. Scraped 20,000 matches, all in the Dayton, Ohio area, and basically looked for patterns. And that's how I came up with this table that maps the percentage of games won to the performance gap. So this table shows that if you won 0 games, then what TennisRecord.com thinks is that you performed at a 0.48 rating worse than your opponent. And conversely, if you won 100% of the games, then you performed 0.48 better than your opponent. Here's the 50%. Again, if you won exactly 50% of the games, then that means you performed exactly the same as your opponent. And so the performance gap is 0. There's no difference between how your opponent performed and how you performed. And so on and so forth. So I made this table based on just analyzing the data that I scraped off of TennisRecord.com, and then I graphed it, which of course Google Sheets makes fairly easy to do. So on the x-axis here is the percentage of games won by me, or the player that you're interested in, and then the y-axis is the performance gap. So again, if you won 50% of the games, then there's a 0 performance gap. If you won 100% of the games, then it's 0.48. If you won 0% of the games, your opponent won all the games, it's minus 0.48. So anyway, I graphed it, and you can see that there's a clear pattern here, but and I so wanted this to be just a straight line, just a linear relationship between percent of games won and performance gap. But it is while it is close to being linear, you can see that it is not exactly linear. And hence the lookup table. If it was exactly linear, I would have just written just an equation for it. But it's not. So to try and be as accurate as I could have done a best fit line to approximate it, but I didn't. I wanted to be as exact as possible. So hence the lookup table. Okay. So now on to the next thing, which is, are there known exceptions to this rule of using this lookup table to map from the percent of games won to the performance gap? And of course the answer is yes. The one very common exception that I found is when the rating gap between the player and the opponent is so large that the lookup table just doesn't work. And so let me give you an example. Suppose we have a player who, going into the match, his current dynamic rating, let's say it's a 3.90. And let's say the opponent going into the match has a rating of 2.90. Okay, so a whole point below the player. Now, what's the expectation here? The expectation is that the player is probably going to win 6-love, 6-love. Maybe not, but that's more often than not, that's what you would expect in this scenario because the player's rating is so much higher than the opponent's rating. That's what you'd expect. So what does that mean? That means that the player won 100% of the games, right? Well, if we look up in our table what the performance gap is, excuse me, when a player wins 100% of the games, the performance gap normally is supposed to be 0.48. And in fact, it is. If you look at the data in most matches where one player wins 6-love, 6-love, TennisRecord.com will assume a performance gap of 0.48, and so it'll say that's how much better than your opponent. That's how much better you performed than your opponent. But in this example, if we were to use that logic, then what it would say is that the player's performance in this match was a 2.90 plus a 0.48 equals 3.38. So it would say, if we use the normal logic, it would say that the player performed at a 3.38. But that's not really fair, is it? Because the player is actually a 3.90, and you can't do any better than 6-love, 6-love, right? You can't do any better than that. So it's a little unfair to the player to say that he only performed at a 3.38. So, long story short, there is a separate set of rules for when the player and the opponent have a wide gap to begin with, that their current rating gap is very large. And by very large, I mean when the current rating gap is greater than about 0.38. And, again, I wish it were a nice round number that was easy to remember. I don't know why it's 0.38, but this is just what I have discovered by scraping 20,000 matches and just analyzing the data. When the rating gap between the two players going into the match is bigger than 0.38, then that lookup table that I showed you earlier does not apply. There is a different formula that applies, and that is encapsulated into the spreadsheet already. So that's what this adjusted performance gap is, and that's the difference between the raw performance gap and the adjusted performance gap. The raw performance gap is just based on the lookup table, just straight looking it up in the table. The adjusted performance gap is the same as the raw performance gap if the players are relatively close together in terms of their rating going into the match. In this case, Ajay was a 3.50, the opponent was a 3.72. That's relatively close. They're not hugely mismatched. So in that case, there's no adjustment that needs to be made. The performance gap is minus 0.15, and we're good to go. But if in the situation where the opponent was, let's say, rated a lot higher than the player, so let's make this opponent a 4.50 and then see what happens. Now the lookup table still tells us, because Ajay still won 36.84% of the games, the lookup table tells us that the performance gap was minus 0.15, but there's an adjustment that needs to be made because their ratings were so far apart to begin with. So it's actually going to say that Ajay performed 0.38 worse than his opponent instead of the normal 0.15. So let me show you a quick graph that demonstrates this. And again, this is just purely based on data that I scraped off of TennisRecord.com. Okay, so what this scatter plot is, what it's showing, is each of these little blue dots represents a match that was played within the last year or so in the Dayton area where the final score in the match was 12 games to 3. So in other words, maybe it was 6-love, 6-3, 6-3, 6-love, 6-1, 6-2, something like that. But matches where the total number of games won by the stronger player was 12, and the weaker player got 3 games total in the match. And each of these dots represents one of those matches. Now on the x-axis, what we have is the rating gap of the two players going into the match. So before the match began, for example, there was a difference in the ratings between the two players of 0.2 or 0.4, 0.6, etc. And the y-axis is showing the performance gap that TennisRecord assigned to the better player. So in other words, if the players going into the match had a rating gap of 0, in other words, they literally had the exact same rating going into the match, and one of the players won 12 games to 3 games, then that better player got assigned a performance gap of 0.34 for that match. And so anyway, you can see basically that the performance gap is the same for every match as long as the player's rating gap going in was less than 0.38. Here's about 0.38 right here. So as long as the rating gap before the match was less than that, the performance gap, the resulting performance gap on a 12-3 score was about 0.34. But as soon as the rating gap of the players going into the match exceeded 0.38, then you see a different line here. It starts, sloping up. And again, the theory behind that, I think, is just that if the players going into the match are so far apart in their ratings to begin with, then you don't want to limit the performance gap of the better player. So if the better player won 12-3, you don't want to limit their performance, because maybe they just lost the 3 games due to a fluke, or everybody makes mistakes. So I struggle with defining the exact rationale for this. But it's something along those lines, is that you don't want to limit the performance gap of the better player just because they lost a handful of games. A 12-3 score is still a fairly sound defeat, and so you don't want to penalize that better player for that. So anyway, it ends up being like a piecewise function, like two functions that are joined together at this intersection. So anyway, so I just wanted to show you that graph as a result of the scraping I did of all the matches with a 12-3 score. And I've got other graphs here for other scores. For example, if it was 4-12, so one player won only 4 games, the other player won 12 games. Again, you see the same kind of effect. This is kind of a mirror image because it's the reverse situation. I'm looking at this now from the weaker player's perspective. And so anyway, you can see again that the performance gap is pretty constant up to a certain point, but when the rating gap of the players going into the match exceeds a certain amount, then the function changes. So anyway, so I just wanted to show you that. I thought you might find that interesting.